Welcome to Surds Level 6, one step in a level by level practice course. Pause the video now, try the problems on the screen, and I'll go through them with you shortly. At the end of the video, you can use the end screen to either practice more at this level or move on to a different topic, and you can find topic by topic playlists on the channel homepage. In problem 1, we're asked to show that this expression is an integer. Now to start, instead of trying to combine the fractions straight away, I'm going to expand, simplify, and then rationalise each one independently before combining them at the end. So starting with the numerator of the first fraction, I'm going to expand. And if you'd like a bit more help with expanding brackets in general, take a look in the top right corner where you can see my course on expanding brackets. Now back to the problem, so 2 root 3 multiplied by root 3 gives us 2, and then root 3 times root 3 is 3. So we get 2 times 3. 2 root 3 multiplied by minus 1 gives us minus 2 root 3. 5 multiplied by root 3 gives us plus 5 root 3. And finally 5 multiplied by minus 1 gives us minus 5. And we can simplify here. So we have 2 times 3, which is 6, minus 5 gives us 1. So this becomes 1. And then minus 2 root 3 plus 5 root 3 gives us plus 3 root 3. So the numerator of the first fraction is equivalent to 1 plus 3 root 3. We can now rewrite that first fraction as 1 plus 3 root 3 divided by root 3 plus 1. And now we're in a better position to rationalise. And we can rationalise this by timesing the top and bottom of this fraction by the conjugate of the denominator. And the conjugate of root 3 plus 1 is just root 3 minus 1. We just change the sign in the middle. We're going to do the same with the numerator and put everything into brackets so that when we multiply, we do this as accurately as possible. So starting with the numerator, we've got 1 multiplied by root 3. That just gives us root 3. Next, we have 1 multiplied by minus 1, which is minus 1. We have 3 root 3 multiplied by root 3. This gives us plus 3 times, and root 3 times root 3 is just 3, so we get 3 times 3. And finally, 3 root 3 multiplied by minus 1 gives us minus 3 root 3. In the denominator, we can multiply it in a very similar way. So we have root 3 times 3 is 3. Root 3 times minus 1 is minus root 3. 1 times root 3 gives us plus root 3. And finally, 1 times minus 1 is minus 1. And we continue to simplify in both the numerator and the denominator. So starting with the numerator, we have root 3 and minus 3 root 3. So that gives us minus 2 root 3, because 1 root 3 minus 3 root 3 is minus 2 root 3. Next, we have minus 1 plus 3 times 3. So that's minus 1 plus 9, which gives us plus 8. In the denominator, as expected when we rationalise, the surds cancel out. The minus root 3 and the plus root 3 become 0, and we have 3 minus 1, which is 2. Now, because minus 2 root 3 and plus 8 can both be divided by 2, we can simplify one step further. And so we can divide the 8 by 2 to give us 4, and minus 2 root 3 divided by 2 gives us minus 1 root 3, or just minus root 3. And the only reason I've swapped those around is because it's a bit neater to have the positive value first. Now that we've simplified the first fraction, we can move on to the second one. Now looking at the second fraction, the numerator can't be simplified at the moment, so we can just go straight into rationalising. And we're going to do the same thing we did earlier, which is to times the top and bottom of this fraction by the conjugate of the denominator. And the conjugate of 2 root 3 minus 1 is 2 root 3 plus 1. So we'll do that to the bottom and the top. And again, we're going to put everything into brackets so that we can expand really accurately. So starting with the numerator, we have minus 7 times 2 root 3, which is minus 14 root 3. Next, we have minus 7 multiplied by 1, which is minus 7. Next, 3 root 3 multiplied by 2 root 3. Well, 3 times 2 is 6, so we get plus 6. And root 3 times root 3 is 3. So we have 6 times 3. And finally, 3 root 3 times 1 is plus 3 root 3. In our denominator, we're also going to expand. So 2 root 3 times 2 root 3 gives us 2 times 2, which is 4, and root 3 times root 3, which is 3. So 4 times 3. 2 root 3 times 1 is plus 2 root 3. Minus 1 times 2 root 3 is minus 2 root 3. And minus 1 times 1 is minus 1. Continuing with the simplifying, on our numerator we can collect together some like terms. So we have minus 14 root 3 plus 3 root 3. And minus 14 plus 3 is minus 11, so this gives us minus 11 root 3. We also have a minus 7 plus 6 times 3. Well, 6 times 3 is 18. If we add 18 to minus 7, we get plus 11. In our denominator, again as expected, the surds cancel out because 2 root 3 and minus 2 root 3 become 0. So we have 4 times 3, which is 12, minus 1, and that gives us 11. As with the previous fraction at the very end, we can simplify one step further because the two terms in the numerator can both be divided by 11. And again, I'm going to put the positive term first. So starting with the 11, we have 11 divided by 11 gives us 1. And then minus 11 root 3 divided by 11 just gives us minus root 3. So our second fraction simplifies to 1 minus root 3. To finish off this problem, we now need to put our two new expressions back in to the original expression. So in place of our first fraction, we now have 4 minus root 3. And in place of our second fraction, we have 1 minus root 3. And because we're subtracting them, we also need a minus in the middle, and we need to make sure that this second expression goes in brackets because we're subtracting the whole of that second fraction from the first. Now the minus outside of that bracket can be thought of as a minus 1, and this is useful because we can now expand. So we have 4 minus root 3, and then minus 1 times 1 is minus 1, and minus 1 times minus root 3 becomes plus root 3. To finish off, we have 4 minus 1, which can be collected together to make 3, and the minus root 3 and the plus root 3 just cancel out and become 0. So our final answer is an integer, as we were expecting, and that integer is 3. In problem 2, we're given a parallelogram with a base of root 6 plus 2 and a perpendicular height of h. We're told that the area is 14 plus 2 root 6 centimeters squared, and we need to show that the height is 5 root 6 minus 8 centimeters. So to start, we first need to know what the area of a parallelogram is. And the area of a parallelogram is equal to the base multiplied by the perpendicular height, which I'm just going to call the height here. So if we substitute in to this equation what we have from the question, we know that the area is 14 plus 2 root 6. We know that the base is root 6 plus 2, and this just needs to be multiplied by the height. So I'm going to put an h after that bracket, but I could also have put it before. Now we're trying to find h, so we just need to rearrange this and simplify. And what we can do to rearrange and get the h on its own straight away is to divide both sides by root 6 plus 2. And this is going to give us a fraction on the left-hand side. So the fraction we have on the left is 14 plus 2 root 6 all over root 6 plus 2. And on the right, we're just left with h. Now, although we've found the height, we don't have it in the form they've required in the question. So we're going to have to simplify. And the way that we're going to simplify this is first by rationalizing, because we've got surds in the denominator. So to rationalize this expression, we have to multiply the top and bottom by the conjugate of the denominator, which is root 6 minus 2. Again, make sure we put that at the top, put everything in brackets, and then we're ready to expand. So starting with the numerator, we can start with 14 times root 6, which gives us 14 root 6. 14 multiplied by minus 2 is minus 28. Next, we have 2 root 6 multiplied by root 6. This gives us plus 2 times, and root 6 times root 6 is 6. And finally, 2 root 6 times minus 2 gives us minus 4 root 6. Similarly, in the denominator, we're going to expand. So root 6 times root 6 is 6. Root 6 times minus 2 is minus 2 root 6. 2 times root 6 is plus 2 root 6. And 2 times minus 2 is minus 4. So simplifying further and looking at the numerator, we have 14 root 6 minus 4 root 6, which gives us 10 root 6, because 14 minus 4 is 10. We also have minus 28 plus 2 times 6. Now 2 times 6 is 12, and minus 28 plus 12 is minus 16. In our denominator, As expected, when we rationalise, the minus 2 root 6 and the plus 2 root 6 cancel out, so we have no surds left, and we have 6 minus 4, which is 2. To finish, 10 and 16 can both be divided by 2. So 10 root 6 divided by 2 becomes 5 root 6, and minus 16 divided by 2 becomes minus 8. So the height is 5 root 6 minus 8 centimetres, as we were given in the question. And that's the end of problem 2. In problem 3, we're asked to show that this expression can be expressed in the form a root 5 plus b, where a and b are constants to be found. So the way that I'm going to go about this is to rationalise each of those fractions first and then subtract. I could subtract first, but it's going to be much easier to collect those two fractions together if we don't have surds in our denominator. So starting with the first fraction, 3 over root 5 plus 2, I'm going to times top and bottom of the fraction by the conjugate of root 5 plus 2, which is root 5 minus 2. Put everything into brackets and then expand. I'm going to start expanding on the numerator. So we have 3 times root 5, which is 3 root 5, and 3 times minus 2 just gives us minus 6. In the denominator, we have root 5 times root 5, which is 5. Root 5 multiplied by minus 2 is minus 2 root 5. 2 times root 5 is plus 2 root 5. And finally, 2 times minus 2 is minus 4. Now the numerator can't be simplified at the moment, so this just stays as 3 root 5 minus 6. But as expected, in the denominator when we rationalise, the surds cancel out because minus 2 root 5 and plus 2 root 5 make 0, and 5 minus 4 is 1. So we have a 1 on the bottom. Dividing the numerator by 1 just keeps the numerator exactly as it was to begin with. So 3 root 5 minus 6 is equivalent to our first fraction. Doing something similar with the second fraction now, we can times top and bottom to rationalise, and we're going to times these by the conjugate of 2 root 5 minus 3, which is 2 root 5 plus 3. And again, we're going to make sure that anywhere where we have two terms, we put these into brackets before we multiply. So looking at the numerator, we're going to multiply that bracket by 1. And when you multiply anything by 1, it just keeps it the same. So this stays as 2 root 5 plus 3. In the denominator, we're going to expand. So 2 root 5 times 2 root 5 gives us 2 times 2, which is 4, and root 5 times root 5, which is 5. So 4 times 5. Then 2 root 5 times 3 gives us plus 6 root 5. Minus 3 times 2 root 5 is minus 6 root 5. And minus 3 times 3 is minus 9. Now the numerator can't be simplified at the moment, so that stays as 2 root 5 plus 3. And in our denominator, again as expected, the plus 6 root 5 and the minus 6 root 5 cancel out. So we're just left with 4 times 5, which is 20, minus 9. And 20 minus 9 is 11. So our denominator is 11. Now because neither 2 nor 3 can be divided by 11, or in fact have any common factors with 11, we can't simplify this fraction anymore. So 2 root 5 plus 3 over 11 is equivalent to our second fraction. We now need to subtract these two terms. So our first fraction, which we can now rewrite as 3 root 5 minus 6, we can subtract from that 2 root 5 plus 3 all over 11. Now here, what we'd like to do is combine the two, but we have different denominators because the first expression that we found earlier actually has a denominator of 1. So what we need to do is create common denominators, combine these, simplify them, and hopefully get them in the same form as we're given in the question. So to make the first fraction have a denominator of 11, we can multiply top and bottom by 11. So we have 11 times 3 root 5 minus 6 all over 11 minus 2 root 5 plus 3 over 11. And now that the denominators are the same, we can collect them together. So I'm going to do this at the same time as expanding that first bracket. So we have 11 times 3 root 5, which is 33 root 5. 11 times minus 6 is minus 66. We then have minus, and we have to make sure that the expression from the numerator of the second fraction goes in brackets because we are subtracting the whole of that expression. So we have the 2 root 5 plus 3 in brackets. At the bottom, we have our denominator, which is 11. Now the minus in front of that second bracket is equivalent to having a minus 1 there. And this helps because we can now expand that second bracket. So our fraction becomes 33 root 5 minus 66. We have minus 1 times 2 root 5, which is minus 2 root 5, and minus 1 times 3 is minus 3, all over 11. If we now simplify the numerator further, we have 33 root 5 minus 2 root 5, which is 31 root 5, and minus 66 minus 3 is minus 69. And that's all divided by 11. We're nearly there now. We just need to separate the 11 amongst the two terms to get it in the form that's required. So 31 root 5 over 11 can just be written as 31 over 11 root 5. And minus 69 divided by 11 can just be written as minus 69 over 11. So we now have our final expression in the form that's required, where A is 31 over 11 and B is minus 69 over 11. So our final answer to problem 3 is 31 over 11 root 5 minus 69 over 11.